Okay, so again, for the integral of 1 over x, we have natural log of absolute value of x. The last new ones that we looked at on Thursday were for sine and cosine. Okay? IB doesn't require you to be able to do other trig functions. If you do AP next year, or if you do college calculus next year, you'll get into those. But with sine and cosine, the integral of cosine of x dx is sine of x plus c. The integral of sine of x dx is negative cosine of x plus c. And thanks to Mrs. Barbag, we've got this handy way to remember it. Okay? Sine, cosine, negative cosine. If you list it like this, then when you go down the list, you're differentiating. And if you're going up the list, you're integrating. Okay? It's a real easy way to remember it and keep your signs straight. Most of the time the issue isn't whether it's, getting the trig function right, it's getting the actual sign correct. So, and these also are kind of a circle. So if you're integrating sine, you go down to the bottom, negative cosine. The integral of negative cosine is negative sine. The integral of negative sine is cosine. The integral of cosine is sine. It just keeps going that way. So theoretically, guys, you actually could keep, with polynomials, when we took the derivative, eventually we got down to 0. You could, with sine and cosine, keep taking the derivative forever and you'd still be getting some function. Same thing with the integral. You could keep going forever and they'll just keep cycling through these 4 solutions. But those are our rules for integration. I wanted to review them real quickly before we look at what we're going to look at today, and that is, if we know, let's say we know a derivative function, and we know one value of the original function, then what that allows us to do is it allows us to actually solve for what that constant of integration is. Okay? For example, here we have a case where we know that the derivative of f is this function here, 2 times the sine of x minus the square root of x. We know that that's our derivative. We want to find what the original function is. Okay, so obviously if you know the derivative, you're trying to find the original function. That means we're going to do what? You're going to go from the derivative to the original function.
Antiderivative.
Yeah, antiderivative, or take the integral of it. Okay? But just doing the antiderivative of this would give us that plus c, the constant of integration, at the end. Right? That's where this point right here comes into play. Because we know one of the values in the original function, once we integrate, then we're able to plug that value in and actually solve for what c has to be. Okay? So let's take this a step at a time here. If I have the integral of f prime of x, okay, I have the integral of 2 sine of x minus the square root of x dx. Okay. The integral of 2 sine x is negative 2 cosine of x. And how about the square root of x?
Minus 2 for x to 3 halves.
Good. You see this as x to the 1/2 power. That's an x to the n. So we add 1 to the exponent. Now it's x to the 3/2 instead of 1/2. Then you divide by the new exponent. Okay, so divided by 3/2, you flip and multiply, we get it times 2/3. Okay, and then of course we have the plus c. Okay? Now, that equals our original function. However, we need to figure out what c is. So here's where the point that we have comes into play. We know that if x is 0, we have 2 cosine of 0 minus 2 times 0 to the 3/2 over 3 plus c. We know that that will equal 4. Okay? So that's f of 0 equals 4. Everyone understand what we did there? Okay. Now we evaluate, of course this equals 0, but what's cosine of 0? 1. So this is a negative 2 plus c. So c equals 6. And now we can actually write what the function is. Okay? Now we know that the function is f of x equals negative cosine of x minus 2x to the 3/2 power over 3 plus 6. Now, be careful that if you're given f of 0, you don't just assume that the constant is c. Is in this case what the 4. Okay? A lot of times when you plug in 0 for x, yes, everything ends up being 0. But as you can see here with cosine, cosine of 0 isn't 0, so we had to actually solve for what c is. Okay? The one case where you can be sure that when you plug in x, everything else is going to zero out is when you have a polynomial. Okay? If you have just a plain polynomial function and you're given the point f of 0 equals, 4, then yes, 4 would be the constant. But we'll see that later here. Okay? Any questions? Comments, anything? Okay. So let's look at another case here. Here we have the acceleration, the second derivative. We have one value for our velocity, the first derivative, and we have one value for the position. So we're going to need to use this process twice. Okay? So to get the derivative, we'll have to take the integral of the second derivative. So what's the integral of 12x squared minus 4?
X cubed minus 4x.
Okay, 4x cubed, 12x cubed over 3 reduces to 4x cubed minus 4x. Then we have this plus c. So this is going to be f prime of x. Okay. So now, here's where my first point comes in. F prime of 0 is negative 1. So negative 1 equals 0 minus 0 plus c. Obviously c is negative 1. So now I know what my derivative function actually is. It's 4x cubed minus 4x minus 1. And now what are we gonna do? What?
Find f of x.
Find f of x using the same process, okay? So now we're gonna take the integral of f prime. Okay? So the integral of 4x cubed minus 4x minus 1, notice we needed that minus 1, okay? We need the minus 1 in there because that will impact the answer. So what is the integral? When we do this, we're getting f of x. What's the integral of 4x cubed minus 4x minus 1?
X to the 4th power.
Okay, 4x to the 4th over 4 is just x to the 4th.
Minus 2x squared.
Okay, minus 2x squared
Minus x.
minus x, okay? And then we've got the plus c. Good. We got the plus c. And now we'll use this second point that they gave us. F of 1 equals 4. Okay. So, I plug in 4 for f of x. I have 1 to the 4th minus 2 times 1 squared minus 1 plus c. What does c end up equaling? 6. Okay? So c is 6, and now we know our original function. Okay? F of x equals x to the 4th minus 2x squared minus x plus 6.
Can you scroll? 1 second? I want to see the directions.
The directions would be find the original function given this. Okay. Any other questions or? Okay. Try one on your own here. Okay, x cubed minus 2x squared plus 3 is the derivative. F of 0 is 2, so what would f of x be? We'll talk about that in a second.
Yeah, there was very well.
X to the 3rd.
Okay, so 3 times 1 is 2.
No, you can just describe how are they going to compare.
3 times 1.
Just say like
Yeah. Yeah.
I thought it was going crazy.
Yeah, you plug in.
Yeah, don't want to include the answer.
No, you plug in 0, and then you set this equal to 2 and plug in 0.
You have to, because you have to find substitution. So
2 equals.
One's worth x is worth minus 2.
Two.
And it's F0.
Plug in. Which is Really?
Is it N?
You said that you
Are you confident?
I'm confident.
You just killed
Alright, you wanna put it up there?
Yes.
He's a new person.
You better be right.
Are you playing the?
Yes.
Well, first,
Yes.
find interesting.
I feel like that's just probably like the main
What?
thing people were worried about is things in the car.
Minus 2x squared plus 3 dx. So? Oh yeah, f of x.
Because I drove into
what part of you bad?
No, because
Doc David will give you some guidance here.
Plus 3dx. Now what?
F of x.
Mhm.
1/4 x to the 4th minus
2/3 x to the third
plus 3x
plus 3x.
plus.
Yeah, it's a PT Cruiser.
And now what? So 2 equals 4's. Which makes C. C. Two. Wait, is that the final answer, Jay? Is this? Is F of X?
F of x, and then instead of plus c, you would put plus 2. But
I feel like the real answer is just
no, it says find f of x.
I
So
feel like the real answer is just never
Yeah, we were saying was
I think dictating it.
But yes, my dad.
Gives you more responsibility.
Oh wait, sorry. Alrighty, let's take a look here. If you're still stuck, that's okay, take a look up here. Alright, so we first of all integrate the derivative. We integrate the derivative and you have 1/4 x to the 4th minus 2/3 x cubed plus 3x plus c. And the plus c is the part we're trying to solve for here. We were given the y-intercept, okay? Now, if you think about this, think in terms of the fact that this is a polynomial function. Your y-intercept always was that constant on the end of the function. Alright? So if you understand that, you could just write down c is 2. Okay? If you forget, that's fine, because you're going to use the same process that we did. You plug in 0, like these guys did. And when x is 0, your function equals 2. So they solved and they got c equal to 2. And then please don't forget to write your final answer. Your final function is the 1/4 x to the 4th minus 2/3 x cubed plus 3x plus 2. Okay? So, thank you guys. Any questions about parts of that? I understand some of you, with being gone, missed some of the rules, so you're still getting used to seeing the rules and learning the rules, okay? My goal for this week is really to kind of finish nailing down all these rules and really understanding those and using them. As we move forward, I gave you, since you did not have any homework from Thursday, you guys had started in class working on 1 through 7. I know no one got really far, because 1 and 2 each had like 9 parts or whatever. But, so what I did was I gave you 5 through 7, and I gave you those ones because they had a nice mixture. Here you have some e to the x, you've got some square roots, you've got some 1 over x squared, which note, you're not going to use the natural log for this. What are you going to treat this as? X to the n. It's x to the negative 2. Okay? Here you have a couple like the ones we looked at. Because there's no chain rule, what are we going to have to do with this? Foil it out. Okay? You got to foil it out. Because there's no quotient rule, what are we going to have to do here? We're going to have to, I guess, you're going to have to split this up into 3 separate fractions, okay? Note that the denominator is a monomial, so you can split it up into 3 separate fractions, all of them having the denominator of x squared, and then you can reduce each separate fraction and then integrate, okay? Then you had some others here with some similar issues and mixtures there. So I thought those 3 problems had a good mixture using all of the different rules. Then numbers 1, 2, and 3 are just like what we were doing here. So D will stretch you a little bit more, okay, number 3. Notice they don't give you one of the points for their first derivative, but they do give you 2 different points for your original function, okay? On this one, it's going to be important that when you do the first derivative and you put your constant in, you're not going to be able to solve for that. Okay, you're just going to have a plus c in there. So when you take the integral again, don't use c a second time. Okay, you could use d, or you could use c1 and c2. Alright, but you're going to have 2 different variables on number 3d here. So that's why they gave you 2 different points on the curve. Okay? So, now, what we're doing, I'm giving you the remainder of our time now, and then throughout the week, did I Thought I changed it on the Sunday post. Or did I just change it?
I don't know, I was kidding.
Guys, if you look at the Sunday post, alright? Here's what we're gonna do. Oh, that's what yeah.
Okay.
Here's what we're going to do. We're gonna take questions on this tomorrow, okay? And then tomorrow we're looking at 18F. That's what I needed to do. I changed the Friday, but I didn't change there, okay? Tomorrow's homework, I'm actually going to collect, alright? I'm not going to grade every single one of those, but I am going to grade select ones, okay? And I'm not telling you which ones I'm grading, alright? So you need to do all of them,
Wait,
alright?
the homework for tonight or the homework
For
for
Friday.
Wednesday?
The homework
Homework
that you get on Wednesday,
Do what, do Thursday?
no, it's due on Monday, okay? Thursday, we're having career day, so we don't have like class, you have a visitor, okay, who will be in here.
So Wednesday's homework is due Monday.
You'll have, yes, Wednesday's homework is due Monday. You'll have opportunity, those who here Friday, you'll have opportunity to ask some questions, okay? And then I'll collect it also on Friday. At that point, everyone will have taken the test, and we're going to do some test corrections. We're going to work on those. So that's the week.